What's going on, guys? It's the Unhinged Engineer back today with episode 3 of my grad school vlog. So if you didn't already know, I'm pursuing a master's degree in computer science at Georgia Tech, entirely online, while I work a full-time job. And I am 2 weeks into my first class, that class being Robotics AI Techniques, or you may hear AI Techniques for Robotics. So I'm 2 weeks in. I've done 2 of the problem sets, which we'll get into the different assignment types and how they're all graded soon. But 2 problem sets, and I'm working on the first project. I started the first project a couple days ago. Last episode, I kind of just talked about like the fun baby stuff, like baby's first office hours, or just getting acclimated to the program. Nothing really technical. But in this episode, I wanted to talk about the actual assignments and material for the class, because I am super pumped about it. I can already tell the class is going to be valuable, and I'm going to learn a ton, right? So this is going to be a more like technical leaning video with some logistics for the course sprinkled in there. I was reviewing the syllabus last night to kind of like make sure I know like the different things I want to highlight and things I want to talk about. And then I just thought to myself, you know what, why don't I just write my notes on the syllabus and go through it with you? Like, this is all available online. This isn't, proprietary or anything. You can go on the OMSCS website and find this link really easily. So I was like, let's just go through the syllabus together. That's pretty much it. Let's get right into it. So like I said, 2 weeks in, 2 problem sets done, 3 if you count the problem set 0, but that was basically like basic Python. It was nothing really serious. And then starting the first project. And so as you'll see with like the grade weighting, the project is significantly more in-depth and more demanding, right? OMS Hub, which is like a website that, people report how classes were, how many hours they took per week on average, statistics like that for students trying to decide what classes to take. If you go on that website, it says that this one's projected to be about 15 hours a week. This week I hit 12. I've been tracking my hours. I try to track my hours on different things in general, but I was especially diligent this week because I wanted to see. I think that may ramp up a little bit as I get closer and closer to the project deadline, but as of right now, I'm at 12 hours. That's the stuff specific to me. Now let's talk about like the actual syllabus, right? So, course intro, you're going to learn how to program all the major systems of a robotic car from the former leader of Google and Stanford's autonomous driving teams, Sebastian Thrun. So as far as I know, Dr. Thrun's like, I think I'm saying his name right, Dr. Thrun. Very famous professor. I think he also was like a co-founder of Udacity, which is funny because like this course is also a Udacity course. Very famous professor. Does all the lectures, like even to this day. The instructor is a different person, but we're still watching lectures from him, which is pretty cool. Current instructor is also great, but anyway, you will focus on probabilistic inference, planning and search algorithms, localization. All the topics are down here. We'll get to that in a second. I think like this central theme of a self-driving car is kind of like it's like the centerpiece of the class. So it's kind of like sometimes the lectures kind of show it like a carrot on a stick. Of it's like, oh, like you're gonna program a self-driving car with this stuff, which I get. Like on the one hand, I think it's a little optimistic to assume that like we write a 200-line Python file and then say that we're programming a self-driving car repeatedly. But I also get that you want to like motivate students and stuff, so it's really no harm, no foul. But it's just funny that that's like the thing we're like chasing after, right? Which is a perfectly fair thing to chase after. I would love to work on FSD, full self-driving. But speaking of full self-driving, these are like the main techniques that we're going to be talking about and doing projects on. So implementing Kalman filters, particle filters to localize moving objects, implementing search algorithms like A*. I would assume we're going to learn Dijkstra's as well. Implementing PID control, and then a SLAM algorithm, so simultaneous localization and mapping. So that's like, in contrast to the first bullet there, a Kalman filter or particle filter, we're moving through an environment trying to figure out where we are. But SLAM, in addition to doing that, we're also trying to build a map of the environment. So there's a lot more like saving of information and building a map over time. I highlighted the A* bullet here just because something interesting the professor said a little while ago is that a lot of these techniques they're definitely not outdated. I mean, nobody would say that like Dijkstra's or A-star or PID control is outdated, right? These things are all still very extensively used in industry, especially mine, like being aerospace, right? But like, I think the professor mentioned that calling them AI techniques is a little bit outdated, right? It's a little bit of a misnomer at this point. Like when most people think AI, they think like deep learning. So computer vision models like YOLO or ResNet or even like LLMs like ChatGPT, right? And so, back in the day, if a computer could search for a path between two waypoints with Dijkstra's, right, to drive a self-driving car, that was like, oh my God, that's like artificial intelligence, mind blowing, right? But today we would more consider that like autonomy or just like an algorithm. Like when I hear people say Dijkstra's, they don't really say the Dijkstra AI. They say the Dijkstra algorithm, right? So it's just funny like misnomer. He kind of made a joke that maybe the class should be called robotic techniques for AI engineers instead of AI techniques for robotics engineers, right? There's different opinions on that, but anyway, yeah, these are the main topics that we're going to cover here. I'm also excited because I'm familiar with a good amount of these, and the ones I'm not familiar with, I really want to learn, right? So out of all of these, I've worked with particle filters before. I've learned a little bit about common filters, but never actually implemented one from scratch. That's pretty cool. Pathfinding algorithms like Dijkstra's and A-star, I kind of like self-taught myself for projects I was doing, like personal projects. I would say out of all of these, PID control is probably the one that I'm the most familiar with because I learned it pretty extensively in class and then used it multiple times for like satellite control systems, right? I mean, PID is everywhere. And then SLAM, I'm not really that familiar with. I mean, I know what it is. It sounds super cool, and I'm super excited to learn about it. But beyond that, I don't really know how any of it works. Even some of the basic, like localization stuff that underpins these filtering techniques, I was less familiar with than I realized, and so it was good to hammer those fundamentals in, which is cool. Yeah, but my point here being that I'm familiar somewhat with all of these things, and the ones I'm not familiar with are like the reasons I'm here, the reasons I want to take this class and get this degree, which is awesome. So yeah, excuse me. Okay, prerequisites. Python 3. So I actually, I was skimming through this, and then I wrote these notes, and then I checked back in the paragraph and found these sentences from them, right? So it's a little redundant. If you are not fluent in some programming language already, aka Python here, Python 3 being the one for this class, learning Python and coding the projects will be extremely time consuming. And I didn't even read this before starting the project and the problem sets, and that was immediately apparent to me, right? I have been working in Python for about 2 years, like pretty extensively, especially for machine learning. And coming into these projects, understanding Python really well, saves me so much time, right? Because there's very little translation between trying to think about the algorithm that I'm trying to implement and writing it out in Python. Like if you give me something, I'm good enough at this point to write it out in Python in a mostly coherent way, right, with some edits. And so like I was thinking as a contrasting example, I've never written C before. I've written C++, but not C. And so when I'm taking like an operating systems class, which I do hopefully want to take that someday, like if I'm taking an operating systems class and they're teaching me a concept like race conditions or parallelism in general, and then not in addition to learning the concepts they're testing me on, I also have to learn the syntax of C, especially something like C that's so thorny. That's going to be additional work that may or may not be accounted for in those OMS Hub like sentiments from people, right? So that's I think something that I really agree with the instructor on. Like if you don't know Python well, this class will be a lot harder. And I would assume like that goes for machine learning and computer vision and other classes like that. I can just immediately tell from the beginning. Whoops. So yeah. Did I skip a page? No, I skipped all the pages. Whoops. Yeah, so that's Python. This page, there isn't a ton of stuff to talk about. There is a textbook. It seems like kind of an afterthought. Some people said if you're like a really mathematically inclined person and you want like additional depth to understand it better, the textbook is good. I actually do consider myself like one of those people. Like I like to read the fancy notation and stuff. It usually helps me, not hinders. So I might do that at some point, but I haven't yet. The lectures have been sufficient up until now. Canvas is the website, duh. edX is where we'd have discussions. I talked about edX in my last video. Office hours. Yeah, so I went to the head instructor's office hours, also discussed that in my last video. There was another set of office hours this week where we talked about more technical stuff with the problem sets and the projects. I think the TAs run them too. I only saw one mention that was kind of like general stuff about the syllabus, and I feel comfortable with the syllabus at this point, so I didn't really go to that. But there will be, I believe, office hours run by TAs for specific projects or like the exams when they come. So I will be going to those. But yeah, academic integrity policy. Oh, I thought I had a note here. I must have deleted it by accident. In terms of like student integrity, I would say like on the one hand, everybody seems pretty chill, nonchalant. I don't think the instructor is headhunting anybody or any of the TAs. So that's good. They basically said that. We're not trying to headhunt anybody. But they do want like pretty extensive citations, even for stuff from like the lectures. So like as an example, when we were doing localization stuff, there was code in the lectures and then a problem that was like similar but a little bit different. And even though I had to change the code from the lectures to match the problem set in the homework, or the problem in the homework, excuse me, I still was expected to cite that I used the code from the lectures because the structure is the same. I don't really know if I agree with that personally. Like, I feel like the structure of an algorithm should be considered kind of like not common knowledge, but fair game. And then specific implementations for the problem, if that's copied from somewhere, that seems a little more dicey in terms of like plagiarism, right? But that's just my opinion, and I don't think their opinion is unreasonable. I mean, it's a comment line. It's not really a big deal. And if a comment line is going to cover my ass from getting reported to OSI, you better believe I'm going to do it. So at the end of the day, I don't think it's a big deal. I don't think anybody's trying to kill us. So that's a perk. Yeah, there's also, I think they talk about honor lock later, but honor lock's for proctoring, so we'll get to that later. Okay, so yeah, so this is some dates and deadlines. I mentioned earlier the projects are like really big compared to the problem sets. You know, let me just show you the grading really quick, and then we'll go back. So yeah, so 6 problem sets and a syllabus quiz. Problem set 0 is nothing, so it's basically 6 assignments if you include the syllabus quiz. 18% total, 3% each. Fair enough. And then these projects kind of fluctuate, but average around like 13%. So these 3 are like the kind of average workload projects as the instructor explained it, and they're 13% each. And then there's the PID control like mini project, so that's worth half of 1. I don't know if is that around spring break or something? Yeah, it's a little bit before spring break, but I don't really know why they decided to make PID control the smaller one. It kind of sucks for me because that's the technique I'm the most familiar with. But oh well. Anyway, PID project's like a mini project that's worth less, and then the search project is worth more, right? So the instructor said you should expect that to be more work accordingly. And then the midterm and final are 20%. I think it says it somewhere, but it's like 8% for the midterm and then 12% for the final or something like that. But yeah, those are the projects. I think as of now, the workload is reflected in the grading appropriately, so that's good. But let's go back to the deadlines here. Problem sets. So I'm posting this on January 18th. So we are right before here. Problem sets 1 and 2 are due, problem set 1 in 3 days, problem set 2 in, I'm drawing a blank, like a week and a half, just about. And then the project is due February 3rd. So yeah, I'm about like a week and a half to 2 weeks out in terms of due dates, right? So I finished problem set 1 like a while ago, like a week and a half ago, and then problem set 2 like early this week. And I started problem set 3 like middle of this week. There were some lectures I had to watch in the middle there. And yeah, speaking of the lectures are kind of set up that you watch them leading up to the problem set. And so like as you go through the lectures, like you get the material needed for like problem 1 and problem 2, and like by the end of watching them all, you're able to do all the problems. Some people like to watch a little bit of lecture and then do a problem, and then watch a little bit of lecture and then do a problem. I've taken the deadlines very literally. I just like plow through all the lectures and then do all the problems at the end. That's just how I've liked to do it. It's kept me ahead so far. Like I said, I'm like a week and a half to 2 weeks ahead, which is nice. But yeah, like the self-pacing is largely up to you. And honestly, it's a little like anxiety inducing because there are some students who are way, way ahead of me right now. Like there are some students who are done with the first project, which is crazy. Granted, some of those did the class before, but like did the class and maybe dropped it, or yeah, for whatever reason, are taking it again. But still, it's kind of hard to self-pace aside from just anxiously looking at the deadlines and making sure you have sufficient buffer, which is basically my strategy up to now. So we'll see how that lasts. But yeah, I mean, that's kind of where I'm at. I don't think any of these deadlines seem unreasonable. The midterm exam period is a weekend, so I'm guessing you pick a time over the course of that weekend to take it. Yeah, that's everything with deadlines. Grading policy we just talked about momentarily. I guess one thing that's interesting is that an A is 90%. When I was in undergrad, it was mostly 93. I'll take it. I'm not complaining. Yeah, let's talk about extra credit really briefly. So there's these two challenge types. One is the hardware challenges and one is research challenges. The hardware challenges, you have to do like super basic stuff like, get a Raspberry Pi and then talk about how it's used in a robotic system, and then get some kind of sensor and talk about how it's used in a robotic system. And then the last portion of it is like implement an AI algorithm that we learned in class on the platform you have. And then the research challenge is like read a paper on a technique that we learned and talk about how it innovates on it, right? I'm probably going to do like half of the hardware challenges and then half of the research challenges. Like it says down here, you can do half and half and get full credit, which is nice. You also have to do some edX participation, but I'm going to try to do that in general because people have been so helpful and I want to like give that back. Yeah, I mean, I read research papers every day for work, so I can probably sneak one or two relevant to this class in there. And then in terms of the hardware challenges, I was thinking about it, like, I kind of have this entire drone platform with actuators is one thing that you have to talk about. There's sensors in this Pixhawk flight controller, and then, yeah, I mean, that's pretty much it. I got hardware, actuators. I can just talk about what I have. So, yeah, I don't really want to go through the trouble of implementing an entire like SLAM algorithm on that drone yet. That's actually something I want to do someday, but do it like really in depth and not while I'm in class. But yeah, in terms of getting extra credit, because it's only worth 2%, I gotta be time efficient here. But yeah, okay. Anything else? This is honor lock, like I was talking about. I used it for the syllabus quiz. It's not that invasive. That I've used some in undergrad that were like a giant pain in the ass. It's not that invasive, this one. Basically, you just show them your room and it locks down your Chrome browser, and that's really it. It's simple enough. But online grading. Grade scope, you have unlimited submissions. Thank God. I hate limited submissions. I feel like it's really dumb and anxiety inducing for no reason. It doesn't help students at all. But yeah, grade scope, you can submit things as much as you want, which is nice. Yeah, that's pretty much everything. The next video, like I mentioned, will be on the first project. So I'm working on working on the common filter project. Of these topics, I think honestly the projects that are going to be the most valuable to me are this common filter project, like implementing that from scratch, and then doing SLAM, because I've never really learned about SLAM or done a project on it at all. So those are the two that will be the most valuable to me, and I can already tell that I'm learning a lot from the common filter project, which is cool. It's a little weird. I still don't entirely know what I'm doing, but I'm working on it. And by next week, we will either have A, a lot more information, or B, a lot more urgency, because I will be panicking if I haven't made progress on it over an entire week. Yeah, that's it. Thank you so much for watching. I'm the Unhinged Engineer. I make content about software engineering, autonomous systems, drones, all that kind of cool, cutting edge stuff. If you're interested in that area of engineering, please like, comment, and subscribe. And in case you couldn't tell, I'm also vlogging my grad school journey. So hopefully I can get a lot of value from these classes and get a even cooler job than what I already have. Yeah, build cool shit, make tons of money. Every engineer's dream, right? If you're interested in that journey, please like, comment, subscribe. And by the way, thank you all so much for the performance of the last video. It's been astounding. I think before I started recording this, it was at 750 views, which is crazy for this channel because we're still pretty new. So thank you all who watched and commented on that video. Yeah, that's it. Thanks a lot for watching, and I will see you next time.